In today's session, we'll be discussing about properties of rule-based classifier. Then we are going to see the various rule ordering schemes. And finally, we'll conclude the session with how to build a rule-based classifier. There are various concepts in that we'll try to cover as possible. Okay, so when I consider the properties of rule set, in the previous class, we have seen a problem wherein we were trying to classify the given test data with respect to the classes present in the training data set, right? So in that, we actually had the three conditions, if you remember. In the first condition, we were able to classify the records successfully. That is, we got two classes, individual classes, and in the next condition, we had one record being triggered by two different rules, or two different rules covering a single record. That is the second condition that we had. And in the finally, we couldn't classify one of the test data, correct? One of the test data. So these are the three different conditions, or three different ways in which the rule classification will be done. So here the second and the third condition is slightly confusing, or we had an ambiguity as well as there was no classification being done. So how to overcome that particular problem? For that, we have to consider two rules here. One is mutual exclusive. One rule we call it as mutual exclusive, and the other rule we call it as exhaustive. So what is this mutual exclusive, and what is exhaustive with respect to a classification or rule-based classifiers? So first we'll see what is mutual exclusive. When I say mutual exclusive, a rule in the rule set are mutually exclusive if no two rules in R are triggered by the same record. So rules present in the rule set should be mutually exclusive, which means a particular record should not trigger two different rules. As in this example of what we have taken in the last class, when we were trying to classify this vertebrate turtle, we had two rules getting triggered. That is, rule 4 as well as rule 5 was getting triggered, correct? So this, when condition like this appears, it means that the rules in the rule set are not mutually exclusive. So that is what it says. And when I say exhaustive, and all, when I say exhaustive, so what happens with respect to exhaustive? A rule set R has exhaustive coverage if there is a rule for each combination of attribute values. So in the previous case, in one previous example, if you consider this particular record of dogfish, I was not able to identify any class for this, correct? So, but this rule says that this property says that any rule in the rule set should have a coverage with respect to the training set given. But here, for this particular record, we didn't have any coverage, any rule. We didn't had any rule which could cover this particular record, which means the rule set that we have considered in the previous case, which was having some 5 or 6 rules, that is not mutually exclusive, and it is not exhaustive also. So we have to derive the rules in such a way that the rules are mutually exclusive and the rule should be exhaustive also. So when I put these two properties together, it means that every record is covered exactly by one of the rule. At least one rule should be there. At least one rule should be there which will be covering the particular given record in the training set. So that is what the property says to us. So there are two properties, mutually exclusive and exhaustive. So when I say mutually exclusive, this property ensures that every record is covered by at most one rule. So mutual exclusive property ensures that every record will be covered by at most one rule. What do you mean by at most one rule? So that is maximum one rule, or there should be one rule. Okay. So when I say exhaustive, what this tells us, this property ensures that every record is covered by at least one rule. So exhaustiveness ensures there should be at least one rule, and mutual exclusiveness ensures that there should be at most one rule. So both these put together, we can tell that every record is covered by at least one rule. So exactly one rule. So that is what the usage of this property. Now, next what we are going to see is, we will see what happens if mutual exclusiveness is not there, then what is the solution for that. So, and if the exhaustiveness, if the rule is not exhaustive, then what is the solution is that. How we can make that the rules become exhaustive, or the rule set become exhaustive, or the rule set becomes mutually exclusive. So we are going to find the, we are going to look at the solution. So first we'll see how a particular rule set can be made as exhaustive. Okay. So if the rule set is not exhaustive, then what we have to do is we can use a default rule. So this is the solution for the exhaustiveness problem. If the rule set is not exhaustive, then we can use a default rule. So how does the default rule look? What is that default rule? So this is how your default rule looks. So RD represents, it is the reference for that particular rule, which says that this is a default rule. You have an empty antecedent here. So in the last class, I told that I'll be using the word antecedent. Now, what do you mean by antecedent? It is nothing but the attribute test conditions. So here I am having an empty antecedent, which means that I am not specifying any attribute test conditions. And here you are having a class. The left hand part, that is the right hand part, that is the consequent part, which is nothing but your class label. So here I have a default class. So our empty antecedent you have, and a default class you have. So using this particular default rule, we will be able to overcome this exhaustiveness problem. So now the question here is, what do you mean by default class? What is this default class? Which class you will consider as a default class? That is the next question that comes to our mind, right? So for this, I can tell that a class which is not covered by the existing rule can be considered as a default class, which means in the rule set, what you will do is, among the available rules, you will check for which class label there is no rule defined in the rule set. What you are going to see, you are going to see for which class in the we don't have a rule defined in the rule set. So if we have any such class present, then I will take that class to be as a default class. So hope this is understood to you. What is default class? A class which is not covered by the existing rules, which means you have to check your rule set and the class available in the training set. So say consider I have 6 class available in the training set, and I have only 5 rules which are covering 5 classes. I have 6 class in the training set, but in the rule set I am having only 5 rules which is covering 5 classes. Now there is one more class left for which there is no rule defined in the rule set, correct? So that rule or that class, you will take it as a default class. So this is one thing that you can do. There might be another possibility that I have a rule set which is covering all 6 classes present in the training set. In such cases, how to consider a default class? So for that, the solution is, if more than one class is there, then we can go for the frequency method. What is this frequency method is? Which class is frequently repeated? Which class is frequently repeated, or maximum number of repetitions in the training record? That particular class, you will consider it as a default class. So there are 2 ways in which you can do. One, you can see that rule set, and if rule is not covering a particular class, then that class directly you can take it as a default class. Suppose we have a rule set which covers all the classes, or there is more than one class which is not being covered. In such cases, in both these cases, what we can do is we can consider that particular class whose frequency is more. When I say frequency, how do you calculate frequency? in your training data set, what you have to do is just see which class is frequently repeated. Which class is frequently repeated? That particular class you will consider as a default class. So this solves your exhaustiveness problem. So I'll just repeat this again. So what is your exhaustiveness problem? It means that there should be at least one rule. Exhaustiveness property tells that there should be at least one rule which could cover the records given in the data set or the training set. There should be minimum one rule for each record. Suppose if there is no rule which covers a particular class, as in the previous example which we had taken, there was no class label for the vertebrate named as dogfish. So in such cases, we have to use a default rule. So how does our default rule look? So this is how your default rule. So you will have an empty antecedent and you will have a default class. Now what is that default class? Two ways in which you can consider default class. The first one is you will check the rule set with the class present in the training set. For whichever class a particular rule is not defined in the rule set, you will consider that class to be as a default class. And suppose there are more than one such classes present for which there is no rules defined, or there is a rule set which has considered all the possible classes, yet it is not able to classify the test record. In such cases, the default class will be that class whose frequency is greater. When I say frequency, what is that frequency? It is number of times a particular class repeated in the training set. So using this, you can overcome the problem of exhaustiveness. Now, the next problem that we have is mutually exclusive. Suppose consider our rule set is not mutually exclusive. So in such cases, what we can do is, so what is actually mutually exclusive? It means that there is ambiguity in deciding which class to assign. So that is, if such ambiguity exists, then we can tell that the rule set is not mutually exclusive, right? So in order for this, the solution is you will be arranging or you will be building the rule set in two ways. One is you will arrange it in the form of ordered rules, or it is arranged in the form of unordered rules. So you will, while building the rule set, we will follow these two cases. That is building the rule set as an ordered rules and building the rule set as an unordered rules. Now let us see what do you mean by this ordered rule and what do you mean by unordered. So when I say ordered rule, in this approach, all the rules are placed or listed in the decreasing order of the priority. So here I'm going to, while building the rule set itself, I will build the rule set in such a way that the rules are listed based on the priority. And this is listed in the decreasing order of the priority. When I say priority, what is this priority and how am I going to consider priority? So priority can be assigned based on the accuracy, or it can be based on the coverage, or can be based on the total description length, and it can be based on the order in which it is generated. So these are the measures that I consider to identify the priority. Okay, so either I can consider the accuracy as the priority and list the rules based on the accuracy. So most accurate rule will be listed first, and then the second accurate rule, and it goes on. Or I'll consider coverage. Any one of this you have to consider. Don't consider accuracy, coverage both together. It will be very confusing. So either you consider as accuracy as a measure, or you consider as coverage as a measure. So if I consider coverage, the same thing. The rule that covers most of the records will be listed first, and then the second rule which covers the second most records, then that will be listed second, and it goes on. So it will be listed in the decreasing order. Now, what is this total description length here? Accuracy and coverage, so we have seen in the previous class, we have formula to calculate it. Now, what is total description length? If you remember, I have told about this also. So here, the total description length is nothing but number of conjuncts present in your antecedent. number of conjuncts present in your antecedent. Suppose you feel that we know that when the number of conjuncts on the in the antecedent part is more, it is more likely to cover maximum records, because we that will have a lower level view of the data, right? As the we know that as the dimension increases, say consider here dimension, each conjunct you consider it as dimension. As studied earlier in the previous modules, we know that as the number of dimension increases, we will get the lower level details, right? So similarly here, if the description length, that is the number of conjuncts in the antecedent part increases, then it is likely to cover more records. There is the more chances of covering more number of records. So you can consider in that way also. Or you are not considering all this, you are randomly generating in some order, then you can take the priority based on the order in which it is generated. So this is what is your, this is how you perform your ordered rules. Now, when your rule set is constructed or designed or uh, based on this ordered rule technique, then such rule set is also called to be as a decision list. So here, how we will be assigning the class? So we will be assigning the class based on the highest ranked rule. So when I say mutually exclusive, you are having ambiguity, correct? So you are in the previous example for the turtle case, we had rule 4 and rule 5 covering. Both are covering that particular record. Now we had an ambiguity there. So whether to consider R4 or to consider R5. So in such case, what you can do is you take this particular measure, that is order in which it is generated. So in that rule set, which was generated first, rule 4 is generated, right? So you assign the class that belongs to rule 4 to the turtle vertebrate. So that is how you can do it. That is how you can overcome the mutual exclusive problem with respect to ordered rules. So ordered rule set is also called as decision list. Ordered rule set is also called as decision list. So you understood, right? Ordered rules, how we are going to overcome mutual exclusive problem using ordered list. So here you will go, you are listing rules based on the priority. And how are you going to calculate the priority? It can be based on accuracy or coverage or total description length, or it can also be based on the order in which it is generated. For that previous example of turtle case, wherein the vertebrate turtle, which was covered by both R4 and R5, so say consider I take this as the measure, then in that case, I will be assigning the class that belongs to rule R4 to that particular turtle case. So I think you have taken that example in your notebook. What you can do is you can just make a note of this also. So in the with respect to the measure of order in which it is generated, you are going to assign the class of R4 to that particular vertebrate. Okay. So next we'll see what is this unordered rules. So in this approach, multiple rules will get triggered. There is no order in which the particular rules to be listed. So we will be considering the consequent of each rule that got triggered, because you know that when I say mutually exclusive, which means more than one rule will be getting triggered. So what we will do is we will consider the consequent part of it. What is there in the consequent part? We will be having class label, correct? So you just consider the previous example itself. R4 and R5 you had, right? Rule 4 and rule 5. So what is the class for R4? What is the class for R4 and R5? Just put it in the chat. Considering the example, what is the rule? What is the class for R4 and R5? R4 is reptiles, R5 is amphibians, correct? Okay, so now what you do is, just see in the training set, I had asked you to note down the table. Hope you have done it. In that training set, see which is repeated more number of times. Whose frequency is more, whether reptiles is more or amphibian is more. Just see. What is the frequency of reptile in the training set? And what is the frequency of amphibians? Reptiles is 3, amphibians 2. Okay. So reptiles is 3 and amphibians is 4. So that is what is. Now look at this slide here. What I've told, consider the consequent rule triggered, identify the vote. So here vote is nothing but your frequency. Okay. So vote is nothing but the frequency that you have found. So as you told, reptile is having frequency 3 and amphibian is having frequency 4. So what you will do is, whose frequency is more, you assign that particular class. You assign that particular class. So that is what it is. Class with highest vote will be assigned. Since now reptile is having highest vote or the frequency of it is more, you will be assigning assigning reptile 3 or reptile as the class to it. So what we will do if the votes are equal? So in that case, the rule higher in the order will be considered. So if votes are equal, then the rule higher in the order will be considered, because there is no order, there is no particular order in which we are deriving, right? But we would have derived it, we would have constructed the rule set. So if the votes are equal, then we will be taking the rule higher in the order to assign the class. So in that case also, with respect to that also, I think reptiles will be getting assigned to that particular class, correct? Okay, so this is what is your mutual exclusiveness. Solution for mutual exclusiveness. One is with respect to ordered rules and the other one is with respect to unordered rules. So in case of ordered rules, what you are going to see, you are going to derive it in the particular order, and the rule which is higher in the order, you will directly straight away assign that. So in the unordered list, what we are going to do, you are going to consider the vote, you are going to identify the vote, and based on the vote, you are going to assign it. If the votes are equal, what you are going to do, you are going to consider the rule which is higher in the order. Thank you, students. If you have any doubts or queries or for feedback, you can write back to me. Thank you.